Section 3.2 Lines. In the last section we took a look at equations in two variables and their graphs. In this section and the next section we're going to take a look at two special equations of two variables, one that results in lines and another that results in circles. So let's get started. Okay. So the first equation in two variables that we're going to take a look at today is the following. Okay. The following equation in two variables. We have ax plus by plus c is equal to 0. Okay, it's an equation in two variables. Results in a graph of a line. Okay, so this equation, because the degree is 1, will give you a line. I think I mentioned that in the last section. Anytime you have an equation in two variables with degree 1, you're going to get a line. So this is the general form of an equation in two variable whose graph results in a line, where, just so you guys know, where a, b, and c are just real numbers. Okay. Now there's many different forms of this equation. For example, if I isolate y by moving the ax and the c term to the left and dividing by b, I get a different equation, and so on. So there's many different forms of the same equation. Okay. So before I get started by showing you all the different forms, let me go ahead and talk about one very important concept whenever we talk about lines. Okay, the idea of slope. Anytime you talk about lines, you're going to have to deal with something called slope. Okay, so what is slope? So a slope of a line, the slope of a line is the steepness of a line. Usually whenever you ask students what is the slope of a line, the first thing they'll say is rise over the run, which is true, but what that results in is how steep the line is. For example, if the line is horizontal, the slope is going to be 0, but as the line increases in steepness, the slope will get bigger and bigger. Okay, so, and the slope is usually always denoted by the letter m. So let me write that down. The slope of a line is denoted by m. You don't have to, but usually that's a convention people use. So the slope of the line is the steepness of a line, and it's denoted by letter m. Let me talk to you about some things to note about the slopes. Okay. Slope is a very important concept, and it's very important that you know all the different things about the slope. Okay, because you're going to use this a lot, especially if you move on and go to calculus and things like that. You'll need the idea of slope. Okay, so let's start with the first one. If the line is horizontal, then the slope is what? What did I just tell you? The slope is going to be 0, because if the line is horizontal, it's flat, it has no steepness. So then the slope m is 0. Okay, so that's the first thing you need to know about the slope of a line. On the other hand, if the line is vertical, then what do you think the slope would be? If the line is vertical, you think about it. If you think about this horizontal line, as the line increases in steepness, you can see the slopes getting bigger and bigger. But when the line becomes vertical, the slope should be infinite, right? Because you cannot calculate something like that, because it's completely steep. Okay, if the line is vertical, then the slope m is infinite, or we say it's undefined. And I'll tell you mathematically why that is in a second too. Okay, that's a nice thing to know about those two things about the slope. Here's another thing. If the slope is positive, eh, if the slope is positive, and I'll write it with greater than 0, this basically means it's positive. This implies that the line is rising. Is going up, is increasing. Okay, so for example, if the line is going like this, that means the slope is positive. Now if the line is rising, that also implies the slope is positive, so this result goes in both directions. If the slope is positive, implies lines rising or increasing. If the lines are increasing, that the slope must be positive. Similarly, if m is less than 0, when we say something is negative, when less than 0 means negative, this implies the line is falling. A better way to say that, it's decreasing. It's going down. So it's something like this. In this case, the line's going down. Okay, and this also goes in both directions. If the line is decreasing, then the slope must be negative. If the slope is negative, the line must be decreasing. Let's take a look at the next property about next thing to know about slope. The next thing to know about slope is this. If you have let's do this. Let's finding the slope. Let's do that. Finding the slope of a line. How do we find the slope of a line? Well, there are a couple different ways to do that, so let me give you all the possibilities. One is if you're given the equation of a line. And by that I mean is you're given something like this. This is the equation of a line. Remember we talked about that. Okay, so this is a line because the degree of x and y is 1. So if you're given that, I can easily find the slope. Okay, so if you're given that, given the equation of a line, all you have to do is isolate the y variable. Once you do that, the slope is then the coefficient of the x variable. Coefficient of the x variable. So once you isolate the y variable, then the coefficient of the x variable becomes your slope. So for example, okay, if you're given something like this, if you're given ax plus by plus c is equal to 0, okay, if you're given an equation like this, okay, if I isolate y, so I go by is equal to minus ax minus c, you divide everything by b, then this term is my slope. So this would be my m, my slope, the coefficient of the x term. So if you want to find the slope, one way is if you're given the equation of a line, you can easily find the slope by isolating the y variable, and the coefficient of the x variable becomes your slope. That's one way to do that. Another way to find the slope is if you're given 2 points on the line. So another way to find the slope is if they give you the 2 points on the line. So in that case, the slope is given by this formula. So let's say if you're given 2 points, I'll call the first point x1, y1, and the second point x2, y2. Okay, so my slope is given by this formula. Slope is m. It's given by the difference of the y value. So you go y2 minus y1. Divide that by the difference of the x values, x2 minus x1. Y represents the vertical values, and if you take the difference of the Y values, you get the vertical rise. And the X represents the horizontal values. If you take the difference of that, you get the run. So that's why the slope is referred to as rise over the run. So that's the second way to find the slope. The third way to find the slope is if you're given information about two lines. Okay, so the third way to find the slope is you're given information about two lines. For example, if they tell you if line 1 is parallel to line 2, so it stands for parallel. So if line 1 is parallel to line 2, then what can we say about their slope? Remember, the slope is a steepness. So let's say line 1 is like this and line 2 is like this. Okay, even though they're not the exact same lines, one line is shifted up. In terms of steepness, they're exactly the same. They're traveling at the same angle, if you can think of it in that terms. So in terms of steepness, they are the same. Then the slope of the first line is equal to the slope of the second line. So if the two lines are parallel, then their slopes are the same. Similarly, if line 1 is perpendicular to line 2, so if you have two lines that are perpendicular, then the product of their slopes, if I take the product of their slopes, we end up with -1. A better way to look at this is, instead of writing it this way, or you can say m1 is equal to, you can divide both sides by m2, so you get -1 over m2. So that's a better way to look at it. The slope of the first line is equal to negative reciprocal of the second line. So those are your three ways to find the slope. So this is pretty much everything you need to know about slope. Okay, if the line is horizontal, the slope is 0. If the line is vertical, the slope is undefined. And you can see why that is. Let me go back and show you that. If the line is vertical, so let's say if I have a line like this point, let's say, is 2, 3, and this point over here is 2, 1. Because if the line is vertical, clearly the x values are going to be the same. Okay, because the points are on the same line. Okay, so now if I try to find the slope, what do? Let's just take a look at this thing here. How do I find the slope? I take the rise, which would be, let's call this x1, x2, y2, and this one x1, y1. So how do I find the slope? y2 minus y1, so you get 3 minus 1 divided by x2, 2 minus 2. So you get 2 over 0. Can we divide by 0 in algebra? No. That's why this is undefined, because we cannot divide by 0. So if the x coordinates are the same, when you're trying to calculate the slope, you're going to be dividing by 0. So you can see why vertical lines have infinite slope or undefined. The slope is undefined. Okay. It's just that we say it's undefined is because the value of the slope gets so big that there's no way to attach a value, a number to it. So you can think of it as undefined, or you can think of it as infinite slope. Okay. If the slope is positive, then the line is rising. It's going up, or increasing is a better way to look at it. I prefer to say increasing. If the slope is negative, then the line is decreasing. It's going down from left to right. Then we have three different ways to calculate the slope. Okay, so we'll take a look at all of these methods in a second when we look at examples. So let's start by taking a look at some examples. Actually, before I do that, let me go back and talk about those different forms of the equation of a line. So let's take a look at different forms of an equation of a line. Okay, there are a couple different ways you can represent a line. So let's take a look at that. One is what I gave you earlier. You have ax plus by plus c is equal to 0. This is called the general form, and sometimes it's also referred to as the standard form. The second form is this, where you have y isolated, so we get mx plus b. Okay, and again, this b has nothing to do with this b, just so you guys know. Okay, but remember we talked about earlier, when we want to find the slope, we can isolate the y term, and the coefficient of x is your slope. So we're calling the coefficient of x our slope here. This is the coefficient of x, a number in front of x, so that's my slope. So this is called the slope intercept form. So let's take a look at why that is. Well, if I wanted to find the y-intercept from the last section, you remember, how do I find the y-intercept? We said x to 0. So if you want to find the y-intercept here, if you set x to 0, what do we get here? We get y is equal to 0 plus b. So we get y is equal to b. So you can clearly see this b happens to be the y-coordinate of the y-intercept. Okay, so here's my y-intercept here. So you can see that. So this form not only tells you, when you write it in the slope-intercept form, not only do we know the slope, but we also know the y-intercept. So those are important things. Okay, so let me just write that down here. This is my slope, and this is the y-intercept 0b. Okay, I always prefer the equation of a line in this form because I think it tells you a lot more than it gives you a lot more information. Okay, the next form for the equation of a line is this. We have y is equal to m times x minus x1 plus y1. This is called the point slope form. In the previous example, it's called the slope intercept form because you know the slope and you know the point intercept. This is called the point slope form because you know the slope. This is still the slope, and this x1 and y1 give you the point on the line. So this is a point on the line. So it's called the point slope form. So you have a couple different ways to calculate, to represent the equation of a line, and these three equations can also be used to find the equation of a line. Okay, initially for some of the problems that we will start, they'll give us the equation of the line, but as we keep working through them, you'll realize we'll have to find the equation of the line. Okay, so let's get started with this. Okay, so let's start examples. So alright, let's get started. So let's say the first thing we'll do is just some simple examples. Let's say we want to find the equation of a line that passes through the points -2, 3, and 4, 5. So I want to find let's make it a little bit difficult, 6. So I want to find the equation of a line that passes through 2 points. Okay, now if you look at all of these methods to represent the equation, we can also, like I said, use all of these equations to find the actual equation of the line if we're given some stuff. Okay, so to find the equation of a line, always remember, I'll just put a note. To find the equation of a line, because that's what they're looking for. They're looking for the equation of a line. Okay, we need to know the slope, okay, and a point on the line. Okay, so to find the equation of a line, you always need to know the slope, you have to know the slope, and you need to know a point on the line. Without those two things, you cannot find the equation of a line. Okay, so anytime they ask you to find the equation of a line, right away the first thing you should ask yourself is, do I know the slope and do I know the point on a line? If I don't, I cannot do it. But if I know those two things, I can easily find the slope. Sometimes they won't give you both of those things outright, they'll make you work at it a little bit, but that's okay if you at least understand that you need those two things. Alright, so let's get started over here. So I want to find the equation of a line. Okay, they've given me 2 points. Well, I only needed 1 point on the line, so that's fine. They've been generous and given us an extra point. That's not a big deal. That's a good thing for us. But the reason why they've given us the 2 points is to find the first thing, the slope, because we know we can find the slope given 2 points. So we're going to use this formula to calculate the slope. Once we have the slope, we'll use one of these points to find the equation of a line. Okay, so the equation of a line basically is just a formula that relates the x and the y value of every point on the line. Okay, so just keep that in mind. These three forms of the equation, what are they doing? They're relating the x and the y value of every point that is on the line. If the point is not on the line, then that x and y value will not satisfy this equation. That means the two sides won't be the same. So it's just out here you can see this x and y value are related by this formula. Okay, so an equation of a line relates the x and y values of every point on the line. Now, like I said, there's many different ways to find the equation of a line. You can use this formula, you can use this formula, you can even use this one, but that one requires a little bit more work. Okay, but the bottom line is you can use one of these formulas to find the equation of a line. So to be consistent, we need to pick one and stick with it, so that way we don't get confused. I'm always going to use this to find the equation of a line. The reason for that is it tells me exactly what I need to find the equation of a line. I need a slope, I need a point. So I'm always going to use that formula to find the equation of a line. So let's go back to this example. They've given us 2 points, so let's find the slope first. Slope is given by rise over the run, or difference of the y values, divided by the difference of the x values. Okay, so let's go ahead and label some of these points something. It's always a good idea to label them. I'll call this x1, y1. I'll call this x2, y2. So it's always a good idea to do that. So my slope is y2, which is 6, minus y1, which is 3, divided by x2, which is 4, minus x1. Make sure you put parentheses since x1 is negative. Okay, so we end up with 3 on the top, 4 plus 2. So we end up with 3 over 6, which is 1/2. So now I know my slope, which is 1/2. Okay, and I know the point on the line. I actually know 2 points on the line. I can pick one of them. I'll just pick this one since I already called it x1, y1. So let's do that. So now to find the equation of a line, I'll take my slope, which is 1/2, and my point, which is negative 2, 3. Remember, this is x1, y1, and I'll use the following formula to find it. Y is equal to m times x minus x1 plus y1. So this is the formula we're going to use to find the equation of a line. Okay, it is a point slope form. This is the point, this is the slope. So let's plug in everything here. So we get y is equal to 1/2 times x minus of minus 2. Make sure you put parentheses, plus y1, which is 3. So you get 1/2 times x plus 2 plus 3. For some reason, students have a tendency to leave the answers like this, but it's not good. We can always distribute and clean it up a little bit. So we get y is equal to 1/2 x plus half of 2 is 1 plus 3. So we get y is equal to 1/2 x plus 4. So here's the better answer to that problem. Always isolate y when you write the final answer. It's a nice way to write the equation of a line because it tells you the slope and the y-intercept right away. Okay, so that's how you find the equation of a line. So anytime they ask you to find the equation of a line, please remember to ask yourself, have they given me a point on the line and have they given me the slope? If they haven't given you those two things, then you first should look at finding those two things before you can find the slope, before you can find the equation of the line. Sorry. So let's look at a different problem. So let's say they give you this: find the equation of a line that passes through the point -5 and -3 and is perpendicular to the line, okay, 3x plus 2y is equal to 4. Okay, so let's take a look at this problem. Let me graphically show you what's going on here. We have this point here, let's say it's -5 and -3. There's a line that's going through this point. This is the line whose equation I'm interested in. I want to find this one. I'll call it L1. I need to know this line. What is the equation of this line? But they've also told you that this line that I'm looking for, whose equation I'm looking for, is perpendicular to this other line. So let's draw another line that's perpendicular, that intersects at 90 degrees. So this line is L2, whose equation we do know. It's 3x plus 2y is equal to 4. That's given to us. Okay? Alright. As soon as you read these words, find the equation of a line, the first thing you should have asked yourself is, have they given me a point on the line? Sure they have. That's good. We are good there. Have they given me the slope of the line? They haven't given you that. But they told you something about the two lines you're working with. The line you're looking for is perpendicular to the second line. And we do know something about perpendicular lines and their slope. What do we know? Their product is -1, or the slope of one line is equal to -1 over the reciprocal of the second line. Okay, so let's do that. So the first thing I'm going to do is find the slope of the second line, which is easy because if you're given, again going back to our slope stuff, if you're given the equation of a line, we can easily find the slope by isolating y, and the coefficient of x is your slope. So let's do that. So what I'm going to do here is I'm going to just isolate y. I'm going to just shorten this line a little bit. So this is L2. They've given us to be 3x plus 2y is equal to 4. So I'm going to isolate y, so we get 2y is equal to negative 3x plus 4. I'm moving the 3x to the opposite side. Divide by 2. Y is equal to negative 3 over 2x plus 2. I'm dividing everything by 2. So my slope is what of this line? The slope, I'll call it M2. The slope of this line is -3/2 because it's a coefficient of the x term. Okay, now I'm looking for the slope of my first line now. What do we know? Since these two lines are perpendicular, what do we know? Since L1 is perpendicular to L2, this implies that the slope of that first line that we are looking for is going to be what? You multiply this by a negative because that's what it tells me to do. Multiply by a negative and you just flip that slope. So if I flip it, what do I get? When I multiply it by a negative, it will become a positive, and then when you flip it, you get 2/3. So that is the slope of the first line that you're looking for. Okay, so let's find the equation now. So the slope of the line you're looking for, now I'll call it M, even though I called it M1 here, but now we're done finding the slope, so we can just call it M. We have 2/3, and the point is -5 and -3. So that is my point. So let's find the equation of a line. Again, we always start with this formula. We have M times x minus x1 plus y1. Again, I do want to tell you this. You can use any one of these forms to find the equation of a line, any one of those forms that I gave you, but I always prefer to use this one. Again, that's why I keep using this, but a lot of the time students are used to this one from high school. That's fine. If you are, you can use that. I prefer this one. So this is my x1, y1. So let's just plug everything in. So we get 2/3 times x minus of minus 5. Remember to put parentheses for negative numbers. Okay, so we get 2/3 times x plus 5 minus 3. Now we have to distribute here to get rid of the parentheses because we want to clean up our answer. So we get 2/3 x plus 10/3 minus 3. Okay, we should add these guys up because these are numbers. This is over 1. So let's just do that on the side. We need a common denominator, which is 3. So we get 10 over 3 minus 3 over 1 times 3 over 3 to make the denominators the same. So now it's 3. So we get 10 minus 9. So we get 1/3. So the answer is y is equal to 2/3 x plus 1/3. So there's the equation of your line. Okay, so when you're doing this, you can use the idea of perpendicular lines and do it. Always remember, anytime you see the word equation of a line, look for a point and a slope. Since they didn't give us a slope, but they did tell us that the two lines were perpendicular, so we were able to exploit the idea of perpendicular lines. If you want to check your answers, it's not that difficult to do that, especially if you have your TI calculators. Okay, the first thing you do is go to y equal to here and enter your lines. The line right here is negative 3 over 2x plus 2, so you go minus 3x divided by 2 plus 2. And for the second line, I'm going to enter this one, so we get 2x divided by 3 plus 1 divided by 3. I put in my two lines. You can go to window here and just make sure everything is okay. You can set the minimum maximum values of the y and the x. Everything looks fine. I'll just hit graph. So that's my line, and there's my other line. And even though right now it looks they're not perpendicular, but they are, because it's not the scaling horizontally, there's more pixels here than vertically, so it's a little bit off, but in essence they are perpendicular. There are other modes for scaling. Oops, you can go to modes. I'm sorry, not there. We want to go to zoom. So you can do Z box, Z in and out, Z squared, Z standard. Z standard is minus 10 to 10. Those are your limits on there. So there's different options here that you can set to. Z square, we'll just make it a square. So then you can see it's exactly perpendicular. You can see over here the two lines are perpendicular. So it's a very good idea to, take a few minutes and graph the two lines just to check your answers. So if you set it to Z square, what that does is it makes the horizontal and vertical number of horizontal and vertical pixels kind of the same, so you get a nice square out of it. Okay. Alright, let's do the same problem again, except say that L1 is parallel to L2. So I want to find the equation of a line such that it passes through this point, but now the lines are parallel. So let's do that. Well, everything still stays the same. We know how to find the equation of the second line, right? We isolate y, so we got negative 3/2. So what do we know if they're parallel? If they're parallel, what does that tell me? The slope of the two lines are the same. So what does that tell us? In our case, m1 will equal to whatever the slope of m2 was. What was m2? Negative 3 over 2. So you get negative 3 over 2. So now we know the slope, we know the point, so we can find the equation. So the slope is negative 3 over 2, and the point is negative 5, negative 3. So we can use our formula. Always write your formulas down when you're doing problems. It really truly does help to memorize them. Okay. So this is the formula we're using to find the equation of a line. So the slope is negative 3/2 times x minus of minus 5. Put parentheses around 5 because it's negative, and also around 3. This should be 1. Sorry. Then we can clean the parentheses up a little bit. We get x plus 5 minus 3. We can distribute. So we get negative 3/2 x minus 10/2 I'm sorry, 15 halves minus 3. So now we need to add this. This is over 1. The common denominator is 2, so you get negative 15 over 2 minus 3 over 1 times 2 over 2. So the denominator is the same, 2. So we get negative 15 minus 6 on the top. So we end up with negative 21 over 2. So we get negative 3 halves x minus 21 over 2. So there's the answer to that. So let's graph this again and see if the two lines are actually parallel. Okay. So let me go to equal to. The second equation is the equation, the first equation is the equation of the first line that was given to us. Okay, so I just need to change the second one. So I'm going to make that a negative 3x divided by 2 minus 21 divided by 2. Okay, so then we can graph those. That's one line. Oops. Oh, I used the wrong negative and I always do that for some reason. Let's graph them. That's the first line and that's the second line, and you can see they're exactly parallel. Okay, so it takes a few minutes to check your answers. Use those nice calculators that you have to check your answers to do this. So we learned how to find the equation of a line. I gave you two examples. They're pretty much the same, all the examples on equation of a line. All you have to do is make sure that you know what you need to know to find the equation of a line. We need a point and a slope. The last thing we want to do in this section is, okay, we want to graph lines. So let me show you how to do that. Okay. There are two ways you can graph a line. Actually, there are three ways you can graph a line. So let me show you all of them. The first method is brute force, just like we did in the previous section. So let me start with that. So by brute force, I'll just do examples of each one because they're fairly straightforward. What you do is, let's graph this line that's given to us. 3x plus 2y is equal to 4. Okay. So let's say if you have 3x plus 2y is equal to 4. So you can use any one of these three methods to graph a line. What did the brute force method say? We randomly pick some values of x and then find the value for y and then graph the line. So that's what we're going to do. Okay, so that's one way to graph a line. So let's do that. So here's x, here's my equation, and that creates my point. Now, since it's a line, all you really truly need is 2 points on the line. Once we have those 2 points, we can connect them. So we don't need a whole bunch of x values to pick. We just need to pick 2. So I'm going to pick minus 1 and 2. Okay, so let's see what happens. So let's plug in minus 1 for x. So you get 3 times minus 1 plus 2y is equal to 4. So we get negative 3 plus 2y is equal to 4. So we get 2y is equal to 7. So you get y is equal to 7 over 2. Since we are graphing, I'll change it to a decimal. It's easier to graph decimals. Okay, so my first point is if x is minus 1, y is 3.5. Okay, I do need another point, so let's do that. So let's say 2. So we get 3 times 2 plus 2y is equal to 4. So we get 6 plus 2y is equal to 4. So we get 2y is equal to negative 2 when you move that 6 over. So we get y is equal to minus 1 when you divide by 2. So my second point is x is 2, y is minus 1. So now that I have the 2 points, I can graph this very easily. So let's do that. I'll do it up here. I guess. So this is x, y. I'll just scale by ones. And so on. Okay, so let's see. I need 2 points. The first point is minus 1 and 3.5. Minus 1 and 3.5. So that looks like over here. Okay, so you should always label them. So this is minus 1 and 3.5. Okay, the second point is 2 and minus 1. 2 and minus 1. That looks like this point. Okay, we have our 2 points, we can connect them with a line, and we have a graph of the line. So there's your line. Okay, so and that looks a lot like what we had over here. That's my first line here. You can see that the green line is exactly this line going down here. Okay, alright, let's use a second method. So that's one way to do it. A lot of work to do that one. Each method is easier and easier. So the second method to graph a line is to find, since we only need 2 points, the 2 easiest points to find instead of doing this is to do this: find the x and y intercepts. So the second method to graph a line is just to find the x and the y intercepts, because they're the easiest things to find. So let's take a look at that example again. So we have 3x plus 2y is equal to 4. If you remember from the previous section, to find the x-intercept where the graph crosses the x-axis or touches the x-axis, you set y to 0. So we end up with 3x plus 2 times 0 is equal to 4. So we get 3x is equal to 4. So we get x is equal to 4/3. Okay, so it's roughly 1.33. Okay, so my point is x is 1.3. I'll just round off to 1 decimal place, and 0. So that's 1 point. I need another point, so let's find the y-intercept. To find the y-intercept, we set x to 0. So we get 3 times 0 plus 2y is equal to 4. So we get 2y is equal to 4. So we get y is equal to 2. So my y-intercept is 0 and 2. Now that we have our 2 points, let's graph it. So let's do that. So I have 1, 2, 3, and we have 1, 2, 3. So my x-intercept is 1.3 and 0. So if this is half, 1.3 somewhere here. And the y-intercept is 0 and 2. So if you connect them, we get the line, which is exactly the same as what we had before. You can see that. Okay, so that's another way to graph a line, finding the x and the y-intercepts. The last way to graph a line is we want to write the line in slope-intercept form. And use the slope and the intercept. Okay, so the last way to graph a line is to use the slope-intercept form of the line. Remember, and that is usually how you should always leave your answers anyway, where you isolate y. This is a slope-intercept form, and I think I gave that to you up here. Right here, this is a slope-intercept form. This is the way I always prefer the answers given. This is the way I prefer, this is the formula I prefer to use to find the line equation of a line. But once you find it, I like the answer left in this form. It's much nicer than this. Okay, so let's take a look at that. So let's go back to our same example. We have 3x plus 2y is equal to 4. So this is not in slope-intercept form. We need to isolate y to get it into slope-intercept form. So let's move the 3x over. So you get negative 3x plus 4, and you divide by 2 on everything. So we get 3 over 2x plus 4 divided by 2 is just 2. So from here we can extrapolate two things. We can extrapolate that the slope is the coefficient of x. In this case, the slope is 3 over 2. And the y-intercept is this term. If you remember, we talked about that before, so it'll be 0 and 2. Okay. So you can see by just isolating y, we get two important pieces of information. We get the slope and the y-intercept. So to graph a line, what did we establish a minute ago? We need 2 points on the line. Since we know the y-intercept, we already know the 1 point on the line. Now I only need another point on the line and I'm done. And to find the second point, we're going to use the slope that we just have found. So let's see how to do that. Okay. So let's start with, let's scale it first. Okay, so let's start with a point that we already know. We know which point, 0, 2. So let's start with that. So we know this point. So we have 1 point on the line. If I can find one more point on the line, I can connect them and I'll be done. So how do I find the second point? Well, according to the definition of slope, also is what? Rise over the run. Okay, so let's see how we can utilize that to find the second point. Well, we always do the rise first. Since it's negative, we're going to go down. So we start at this point 1, we go down 1, 2, 3, we come down here. Okay, and then the run is 2, so we go horizontally to the right. Since it's positive, we go 1, 2. That's the second point. So what did we do here? We started up here at my y-intercept, then we went down 3 units, then we went across 2 units. Once we did that, we got another point on the line. We can connect those two to get our equation of the graph of the line. There we go. So that's another way to do that. So you have a choice. You have 3 different ways to find to graph the equation of a line. I always prefer the second method, the finding the x and the y intercept. That's my personal choice, but you can use any one of those 3 methods to graph the equation of a line. Let me do one more example, and then we'll be done with this section. So let's say if you have negative 2x plus 5y is equal to 10. Okay, and I want to graph this line. I'll do it 2 ways. I won't use the first method, but I'll use the last 2 methods that I just showed you. So I'll just draw a line in the middle here. Okay, so let's start with the second method. The second method is to find the x and the y intercepts. So to find the x-intercept, what do? We set y to 0. So we get negative 2x plus 5 times 0 is equal to 10. So you get negative 2x is equal to 10. So we get x is equal to negative 5. So my x-intercept is x is negative 5 and y is 0 from here. To find the y-intercept, what do? We set x to 0. Okay, so we get negative 2 times 0 plus 5y is equal to 10. So we get 5y is equal to 10. So we get y is equal to 2. So my y-intercept is 0 and 2. Okay, so now that we have that, let's graph it. Okay, so we'll scale by 1s up here. And by -1 here, by 1s on the bottom too. So my 2 intercepts are what? X is negative 5, 0 and y is 0, 2. Once we have them, we can connect them with a line and we are done. There's the equation of that line. Okay. Now, to use this third method where we isolate y, so let's do that. So given this equation, minus 2x plus 5y is equal to 10. To be able to graph this, we need to isolate y first. So we get 5y is equal to 2x plus 10. I'm going to move the 2x to the right, divide everything by 5. So you get 2/5 x plus 2. So this tells me my slope is 2/5. Okay, and the y-intercept is the point 0, 2. This is this, that's 0, 2. So I can easily graph this line also now. So we have 1, 2, 3, 4, 5, 6, and we have 1, 2, 3. So I need 2 points to graph a line. I already know my y-intercept, so I know 1 point. Let's find the second point. Okay. So what does it tell me to do? Remember, the slope is what? Rise over the run. So the rise is 2. Okay. So I'm going to go up this time since the rise is positive. Since this is positive, we're going to go up. So we go 1, 2, 2 up, 1, 2. So I'll just draw an arrow just to show you. So we come up here, then horizontally we go 5. So that would be, so we go right there. So that is my second point. I connect those 2 points with a line, and that gives me the equation of that line. So this point will be 4, 5, 4, and this is 0, 2. So I start with my y-intercept, go up 2 units since the rise is 2, and then go horizontally 5 units. You always go horizontally to the right. Okay. One last example of this, just to show you, sometimes students get confused, is when I have something like this. If I have, let's say if I have 2y plus 4x is equal to 6. Okay, let's make it 5 just to be difficult. So let me graph this using the last method where I isolate y. I can still graph this by finding the x and the y-intercepts like I've been doing, but let me do the other way. You move the 4 to the other side, so you get negative 4x plus 5, and then you divide everything by 2, so we get y is equal to negative 2x plus 5 over 2. So my slope here is negative 2, and since there is no denominator, we assume that to be 1. It is 1, not assume, but it is 1. And the y-intercept in our case is this term, the one without x, which is going to be 0 and 2.5. I'll just write it as a fraction. So let's see if we can graph this. Okay. So we have, this is x, y. I'm going to just scale by ones. 1, 2, 3, 4, and then we have 1, 2, 3, and so on. Okay. So I always start with this point because I need 2 points to graph. I know 1, 0, and 2.5. That's right here. Then my slope tells me what? This is my rise. It's negative 2. So I'm going to go down 2 units. So I go from here to here, that's 1. From here to here, that's 2. So I'm going to come here. Okay. Then I'm going to go horizontally 1 unit. So that's just going 1 unit here. So here's my second point on the line. I needed 2 points. I found 2 points. I started with my y-intercept, then I went down 2 units, went horizontally 1, and then you just connect them with a line, and you have the equation of that line. Okay. So if the denominator is not given to you, make sure you recognize that it is 1 and do that. Okay. And if you have, like, for example, if I had this, let's say if I had 2y minus 3x is equal to 6. So you isolate y, so you get 2y is equal to negative 3x. That's positive 3x plus 6. Then you divide everything by negative 2, so you get y is equal to negative 3 over 2x minus 3. This negative, when you divide, you can put that negative anywhere you want. So for example, negative 3 halves is the same as negative 3 over 2. It's the same as 3 over negative 2. It doesn't matter where you put the sign, but when you're graphing using this method, it's always good to put the negative with the number in the numerator. So then you go up or down depending upon whether it's positive or negative. And then that way you always go horizontally to the right because the denominator will always be positive. Okay. So it's up to you how you want to do this. I prefer to do it this way. So those are the equations of lines and how to graph lines. This is a very important concept, so make sure you guys do your homework. There's some other problems in this section that I kind of talked about in the last section, so hopefully you can recall from that section, so you don't have to worry about, you will remember that, so you don't have to worry about when you do your homework. Okay.